So we're starting Unit 3 today, which is on transformations. And we're going to do one flashcard on just basically the transformation language and what they are in general. And then we're going to specifically focus for the rest of class today on rotations. Okay, so we'll do a flashcard on rotations as well. So this is going to be number 11. And the title here is going to be rigid motion. And you're going to find out today and throughout the unit that rigid motion is a way that phrase that we use to describe transformations. So that's what they're actually called in this lovely Common Core curriculum that we like to always use those nasty little words. And so they're referred to as rigid motion, so that's what we're going to refer to them as throughout the unit. Okay? So what is rigid motion? There's another phrase that we can use as just a word for rigid motion, and that's called isometry. I don't know if you guys have heard that word before. It's pretty fancy. Okay, so we're going to say rigid motion or isometry. These words are interchangeable, and we'll probably use rigid motion more than we'll use isometry, but isometry is, again, interchangeable here. So what does this mean? If you have a rigid motion or an isometry, it means that your distance and angle measures of the shape that you're transforming remains the same or is preserved. You guys heard the word preserved before? It means it keeps it the same, okay? So there's a couple things we're going to write down about this, but the most important thing is that distance and angle measure are preserved. Like, you know how jelly gets preserved? I don't know. That doesn't really make that much sense, but distance and angle measure will be preserved. So when you're looking at the shape itself is not going to get any larger or smaller. It's going to remain the same size. Does that make sense? When two shapes are the same exact size, let's say it's two triangles, they have the same angle measures, the same side measures, what do we call those triangles to each other? The three sides of the triangle don't have to be the same, but the three sides of this triangle have to be the same as the three sides of this triangle. So what do we call those triangles? Congruent. So that's the basic general idea of rigid motion, is that the figures are congruent, okay? So here's a little bit more vocabulary for you. The pre-image, have we heard that before? No? And the image are congruent. So when you think about that, it should make sense. Because you know what the image is, right? It's what you get when you transform a shape. The pre-image is the shape that you're given to begin with, okay? So the pre-image and the image, whatever you're doing with it, rotating it, reflecting it, whatever the case may be, those two shapes have to be congruent in order to call it a rigid motion or an isometry, okay? We also talk about, when we talk about rigid motions or an isometry, we also talk about orientation. And this is another word that has lots of meaning in your life right now. Probably you guys all went to 8th grade orientation, right? Or ninth grade orientation at one point in time, right? When we talk about it in terms of our transformations, the orientation is like the order of the points as you go around the figure, okay? So we're going to say the orientation, which is the order of the points, can be direct or opposite. Direct means that the order of the points remains the same as you go around the figure, and you'd have to choose a direction to look in. Opposite means that it's reversed. As we talk about each of the transformations individually, we'll talk about whether or not it's direct or opposite and why. So you just kind of need to know what orientation means right now, and then we'll talk about direct and opposite as we go. Okay? Now, the next thing you need to know is, what is a vector? So, before we talk about what a vector is, we're going to watch a little video from Despicable Me. This is from the first one, right? Yeah. All right, you ready?
I'm applying for a new film loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah! Check out my new weapon. Piranha gun! Oh, yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. You want a demonstration? Oh, ow! I realize it's so difficult sometimes to get blind outside.
Okay, so what's a vector? Did you get it? You were just so focused on. We will in a second.
For a new film role, go by the name of
Okay,
Vector.
listen.
It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
Oh, yeah. Okay, so it's a mathematical quantity represented by an arrow with both
Direction and magnitude.
direction and magnitude. The hand gestures are optional, but if you like to make them, you certainly can. Okay, so that's what a vector is, and you're going to see for two of our transformations, we need vectors to transform because, again, we'll be doing this without a coordinate grid in this unit. So a vector is represented by an arrow. Sometimes I forget how to spell. Okay, so represented by an arrow. It gives us, now do you guys know what magnitude means? Huh? Magnitude would be a length or a distance, okay? So it gives us direction and length. Okay? So it's going to tell us which way to go. Think about like a translation. It's going to show us which way to move it, and it's going to show us, the vector is going to show us how far to move it. Does that make sense? Direction and length? Okay, so that's what the vector tells us. And we use vectors for rotations and translations. So used for rotation and translation. Okay, so the types of rigid motion, there are actually only 3. Although you might be thinking of a 4th transformation, there is a transformation that's not a rigid motion, and that would be what? A dilation, because you're changing the size. You're not changing the shape. It will still be a triangle, but you're changing its size, so it is no longer congruent. It is similar. So that is not a rigid motion. We will be talking about dilations, but we can't classify it as a rigid motion. So the types of rigid motion that you need to know are going to be rotation, and a rotation is just a turn, right? Reflection, which is a flip, and translation, which is going to be the slide. We're going to just draw a quick little picture of each, just so you kind of are picturing what they look like. Okay, so if I had a square, and your pictures don't have to match mine exactly because we're not drawing these with perfection right now. We're just kind of showing ourselves what this might look like. So you might rotate that square so that it's now, whoops, I ran out of room, down here. Okay, so you can really rotate in any direction. You can rotate around a point on the figure, in the figure, outside of the figure, but you'll have to know what that point is. We're going to talk more specifically about rotations today, so you'll see that in a minute. Your reflection is your flip, so if you had, let's say, a right triangle reflected over this line, and this is the hard part, is to try to draw it so that it is a perfect mirror image. So that would be your reflection. And then your translation, I just used a right triangle for this as well, would just be a slide, and it can move in any, it can move up, down, left, right, or a combination of those. Okay, in terms of orientation, again, we'll talk about this more specifically. Your rotation is going to be direct, your reflection is going to be opposite, and your translation is going to be direct, okay? We'll talk about those more specifically when we do each of those transformations, but you can just kind of have that down for your notes. All right, so this is going to be flashcard number 12, and we're going to focus for the rest of the lesson on just rotations. Unfortunately, rotations happen to be the hardest of the three that we have to do. Although translations can be a little bit challenging, the rotations are a little bit more challenging. So we're going to do that today. Get the hard one over with. That'll give you more time to practice it before the end of the unit as well. Okay, so there are some rules involved when you have rotations because you need to know certain things in order to do a rotation or to tell if you have a rotation. So it's important to know that you are going to rotate a certain number of degrees, and remember back to trig how we called our reference angle theta. We're going to be using theta here as well. So we're going to rotate theta degrees about a point using a vector. Okay, so there are some very important things that you're going to need to begin with. You're going to need to know how many degrees you're rotating. You're going to need to know the direction that you're rotating, which we're going to talk about in a couple seconds. You're going to need the point that you rotate around, and then you're going to have to use a vector for each of the points that you're rotating. Okay, so how do you know which direction to rotate? And you might have figured this out by now. That's the difference between if it's positive degrees or negative degrees. So does anybody know positive degrees? So if you have a positive angle of rotation, which way are you going to go? It's counterclockwise. To me, that's counterintuitive. To me, positive seems like it should be clockwise and negative seems like it should be counterclockwise. But do you remember the order of the quadrants? 1, 2, 3, 4? If you go from 1 to 2 to 3 to 4, you're going counterclockwise. So that's why positive degrees is counterclockwise, because it follows the order of the quadrants, which I just did backwards, right? The order of the quadrants, okay? So if you're given a negative degree rotation, then you will go clockwise. And something to note here before we talk about how to do this, rotations are direct, rigid motions. Remember what direct means? The orientation of the letters will remain the same. Now that doesn't mean that A is on top and A prime is on top. That means that as you go, let's say you choose a direction, as you go around the shape, the order of the letters will be the same as you go around the other shape. Does that make sense? So if it's A, B, C, it's going to be A prime, B prime, C prime. But it could be turned. It's just the same direction around the shape. Okay, so that's your orientation. Now, we're going to be focusing for the rest of the class on the constructions related to rotations. Okay, so we're just going to write a couple of notes about how to do this. We're not actually going to put an example of a construction on the flashcard because that's just a little bit too much to put on here. But let's just write ourselves a couple of notes that can help, okay? So when you're constructing a rotation, you're going to start by drawing a vector to each point, okay? That vector is going to start at the point that you're rotating around, and you're going to draw a vector to each of the points in the figure. The vector is what you're rotating, okay? So you're going to figure out how to rotate that vector however many degrees they told you. The very tricky part about this is that to rotate, let's say 90 degrees, you need to construct and copy a 90-degree angle. How do we construct a 90-degree angle? Perpendicular bisector. So you're going to actually like go off to the side and construct perpendicular lines, doing the fishy thing, and then you're going to have to copy the 90-degree angle onto the rotation. This is why this is the one that's the most challenging, because you have to construct your own angle to copy to rotate, okay? So you're going to rotate the vector let's say theta degrees, because it could be any number of degrees. And we're going to do that by using the construction for copy and angle. And remember, the vector has both direction and magnitude. When you rotate it, you've got your direction, but you need your magnitude, which is your length. So you're going to have to copy the vector length onto the new line that you drew. So that's your final step. Copy the vector length. And this is just that copy a segment, the very first construction that you learned. So copy the vector length to get new point. And you're going to label your points with those prime marks. Okay? I just kind of sketched an example on here so that you would be able to kind of visualize what it looks like. So I drew a triangle, and I drew a right triangle-ish, I guess. And we're going to kind of sketch what this would look like if I rotated it 90 degrees about point P. And I'm just going to put point P down here. Okay? So what I want you to visualize is a vector going from P to C. Now a vector looks like an arrow, right? So your vector would go from P to C with an arrow on it. If I needed to take that vector, now you don't draw this on your paper, but I'm going to just kind of like try to pick a lighter color here. I'm just going to draw what it would look like. So here's you would use your straight edge to draw the vector, and there it is, okay? If I needed to rotate that purple line 90 degrees, which way am I going, clockwise or counterclockwise? Counterclockwise. So picture 90 degrees, and I'm going to end up, does that make sense? Okay, so if I have it here and I rotate it 90 degrees, it's going to end up here. Now you're going to have to construct that by constructing a 90-degree angle and then copying it onto the figure. I'm going to show you how to do that. And then you have to copy the vector length, so we can kind of picture that that point C prime might end up right there. Does that look okay? Maybe a little bit further out. Okay, like I said, we're just kind of sketching right now. Okay, if I went from A to P and then did that 90 degrees, that's going to end up maybe up here. That would be my A prime. Okay, and then my B to P, okay, and then 90 degrees would be about up here, and that's going to be B prime. And I just kind of, you can just draw it with solid lines if you want. I just drew it dotted because it's the image. So it's not perfect, okay, but that's about what it would look like if you were to do that rotation. With the compass, there's going to be a lot of construction marks on there, okay? And there's one other thing about rotations that you need to know, and that is rotational symmetry. Have you guys heard of rotational symmetry? No, have you heard of symmetry? I hope so, because you're going to be working with symmetry throughout the unit. Line symmetry is like when you get that mirror image, right? Rotational symmetry is if I take a figure and I can rotate it and make it look the same, then it has rotational symmetry. So you're thinking of just turning it, and would it look the same after maybe a 30-degree rotation or a 60-degree rotation or something like that, okay? So rotational symmetry means the shape looks the same after a rotation about the center. So it'd be in the center of the shape, and if you turned it, would it essentially land back on top of itself where you couldn't tell that you had turned it, okay? You're going to be working a little bit with rotational symmetry next class, so that's why I wanted to point out to you what that is now. I think line symmetry is easier to understand, but rotational symmetry just means that you're turning it and it's remaining the same, okay? So I'm going to show you how to find a center of rotation and how to actually construct a rotation. We're going to do that in the pink packet. We're going to start on page 2. And you can see at the top of page 2 here, it shows you that positive rotation and negative rotation being clockwise and counterclockwise, just as a reminder. Okay, on page 2, the directions to finding the center of rotation are there for you, so we'll just go through and follow these directions, okay? So you're going to connect one of the vertices to its image. So in this case, we only have 2 of them labeled. So we're going to take our straight edge and connect A to A prime. Okay, so you're drawing a line, right, connecting A and A prime. We're going to bisect that segment. How do we do that? Fishy thing, right? So put the tip here, compass is open, more than half. Am I making sense? And you want to make that nice and long because the center of rotation is somewhere on that line. We're going to have to find where it intersects with another one to get the actual center of rotation. Okay, so I connected point A to its image and bisected the segment. You're going to do that again with a different 2 points. Since B and B prime are labeled, let's do that. So you have to try to ignore the construction marks that are already on there. That for me is one of the hardest parts because they can get in the way. As I suggested in the last unit, if you want to switch out with colored pencils, that's perfectly fine. That can be a little, daunting with the compass, but if that would help, that's fine. So I've connected B to B prime, and we're going to do the perpendicular bisector of B, B prime. So we're going to do that fishy thing, more than halfway. Okay, this is where things are starting to collide a little bit more. So you really want to be very careful that you're finding those 2 points. It might be really helpful if you go in and specifically find the 2 points that your fishy is making before you actually draw the bisector. Again, make it nice and long. So then the question is, where do the 2 perpendicular bisectors intersect? So here was my first one. Here was my second one. Are you guys with me on that? So I'm going to even go over them in color. And this is something you could do even if you don't switch out for colored pencils. You could go back over these bisectors in color to help you, or highlight them, okay, if that would help. And where do they intersect? Kind of down towards the bottom, right? So this right here is the point of rotation. Okay? Now, if we want to label the angle of rotation, we have to draw in those vectors that I was just talking about. So to label the angle of rotation, you're going to connect a point to the point of rotation and its image to the point of rotation, and those are not connected right now. I'm going to actually do this with a highlighter so you can see it very easily. So you're going to connect A to the point of rotation. This is going to end up a little bit thicker than it should be, but there's that. And then you're going to connect A prime to the point of rotation. And that is your theta, your angle of rotation. Is this a positive or negative rotation? It is positive. So you look at the vector that goes from A to A prime, move it to the the vector that goes from the point to A and move it to the other one. I just moved in a counterclockwise direction, so it's a positive rotation. Does that make sense to everybody? Okay, I'm actually page 6 in the packet, and I'm going to show you how to actually rotate to figure around a point. This is actually going to be quite a bit of work and a little bit difficult. We're going to have to, as we talked about earlier, actually construct a 90-degree angle so that we'll be able to copy it. And we're going to have to do this for all 4 vertices of the quadrilateral. So this is going to be a little bit of a longer process. So what we're going to do first is connect the point of rotation to any of the points. I'm going to start with D since it's the closest. And we're going to draw the vector that connects E to D. And I can do a little bit better job of that, so let's do that. So again, we're connecting E to D, and we're making that vector, so that would have, you don't have to put the arrow on the end, but that would have an arrow on the end for the vector. So remember, a vector has both direction and length, so we're going to have to take care of both of those. Now, In order to rotate 90 degrees, we need a 90-degree angle. So I'm going to come on to the side of my paper here. I want to keep it out of the way of my rotation. I'm going to draw a segment, and I'm going to go ahead and bisect that segment. You have to construct a 90-degree angle. You cannot just draw something that looks like a 90-degree angle and call it good. Okay, so we're actually constructing a 90-degree angle by drawing a perpendicular bisector of a segment, and then we will be able to copy that 90-degree angle onto our figure over here. So we're going to do that next. Okay, so we're going to copy the 90-degree angle. We're actually going to take this vector from D to E and rotate it 90 degrees. 90 degrees is going to be counterclockwise. Okay, counterclockwise. So that's going to go in this direction. If you can visualize that first, then you can tell where your marks should go for your angle. I'm going to copy my 90-degree angle, so I'm going to know how to put my compass in the middle here. And copying an angle, we start with an arc. I'm trying not to turn the paper too much on here. So we're going to mark that 90-degree angle with an arc, keep the compass the same, come on over here, and mark that around this way. Now I happen to hit D perfectly there. You want to make sure that it's going to be within that vector, so a little bit smaller arc might have been better on that one, but luckily I hit D perfectly. I'm now going to measure the distance that the angle is open. Okay, so from one place where the arc hits the angle to the other place where the arc hits the angle. And I'm now going to mark that from D down here. And it slipped on me. And I have my mark there. So the new vector will go from E through that cross, and now we have to measure the length. Okay, now this is going to be interesting because I had the length pretty perfectly here, but I'm going to measure from E to D, mark it there, swing it down, and mark it down here. Okay, and so the point where that hits the segment that you just drew creates the new vector, so that point is D prime. Okay, you're going to repeat this process for each of the vertices. So now I'm going to connect E to C. There's my vector. I need to swing that vector around, so I'm going to come back over here. Now I'm going to be strategic about this, and I'm going to keep the arc at the same length that it was, so I don't have to keep copying over and over again. So my arc is, I moved my compass so that the arc was at the same length. I'm going to go back to E and swing. Now if you notice, when you do this, this arc is going to be swung directly on top of the arc I already had. So I'm going to go ahead and extend that out, and now that arc is actually copied for any of the vectors that I'm going to have to move. Okay, I'm going to come back over here and measure the opening of the angle, and I'm going to put my point where the arc hit vector EC, swing it around here, moving the paper on you, mark it here. Now when I connect E to that point, my vector will be somewhere on this segment. Okay, and I'm going to get that by measuring from E to C, swinging it down and marking it here, and I just constructed point C prime. We're going to do it again for B. Measure from E to B, not measure, mark it, because that's your vector. So there's your vector from E to B. We already have this arc. We're going to measure again the opening of the 90-degree angle. We're going to put our compass where the arc hits EB, and we're going to swing that down to where it hits the arc on the other side. These lines are very close together, and then we're going to mark that segment from E through that intersection, and I'm going to measure from E to B. Make sure you mark when you measure. Swing that all the way down here, and you have constructed B prime. And we're almost done. We've got A to go. We're going to measure from E to A, again marking that as the vector. Okay. Okay, one more time. We already have this arc, so we're going to measure the distance of the opening of the angle. We're going to put the compass tip where the arc hits EA. We're going to swing it over to the arc on the other side. Okay, so you're always measuring from this arc to this arc over here. We're going to draw the segment that connects E to that intersection. We're going to measure from E to A. We're going to mark that down here, and we have point A prime. And now your moment of truth, connect the points in order. So you're going to connect A prime to B prime, B prime to C prime, C prime to D prime, and D prime to A prime. And it looks like a rotated figure, and so you have rotated this figure 90 degrees about point E. Again, this is a very tough process, so you're just going to have to keep working through these steps. Let me know if you need any help, and I will see you guys soon.